Welcome to Chemistry with Dr. G. In this video, I'm going to talk about reaction profile. What is reaction profile? Before we start talking about reaction profile, we need to understand what happens during reactions that leads to a change in the energy of reactants and products between reactants and products. So, for any chemical reaction to occur, um, it only occurs when reacting particles collide with each other with sufficient energy. So reactants will need certain amount of energy in order for the reaction to start. This is called the activation energy. So activation energy is the minimum energy or the minimum amount of energy that particles must have in order to react or in order for the reaction to start. And we can represent all of that using the reaction profile. So reaction profile can be used to show the following. The first thing is the relative energies of reactants and products. And we know that there are two types of reactions. There are the exothermic reaction and endothermic reaction. We're going to see the difference in the energy between reactants and products using the energy profile. Also, we can see the activation energy, which is needed to or need to be supplied in order for the reaction to start. And finally, we can see the overall energy change for a reaction. So let's have a look and see how can we draw the reaction profile for both types of reaction. Let's start off by exothermic reaction. The reaction profile is a graphic representation of the between the potential energy and the reaction progress. So we start off by drawing the level of energy for both reactant and products. For exothermic reaction, we know that the energy of reactants is higher than the energy of the product. So we represent the energy of reactants by the letter R and the energy of products by the letter P. And then in for the during the course of the reaction or during reaction progress, the first thing we need is the activation energy. So the energy will go up from here to up there in order for the reaction to start. So this is called the activation energy. So the difference here between the highest point and this is called the activation energy. This difference is called the activation energy. And then once we have the activation energy and the reaction starts, then the product will start to form. There will be a reduction or a fall in the energy until we reach the energy of the products. So this is the energy of the products. The difference between the energy of the reactants and the energy of the products, this difference is the overall energy difference or overall energy change. So this is the overall energy change for this reaction. So that's for the exothermic reaction. What about the endothermic reaction? So let's have a look at the endothermic reaction. Again, we have the reaction progress on the x-axis and we have the potential energy on the y-axis. And then we have the energy of the reactants and energy of the products. We know that the energy of the products for endothermic reaction is higher than the energy of the reactants. Now let's represent the activation energy and the overall energy change. First of all, we need activation energy, so there will be some energy must be supplied for the reaction to start. The activation energy is the difference between the energy of the reactant and the top energy. So this is the activation energy. And then the energy will start once the reaction starts, the energy will fall until we reach the overall energy of the product. And the difference in the energy between reactants and product, this difference here is called the overall energy change. As we can see in exothermic reaction, their energy here is given off, so energy given off here. But in the endothermic reaction, the energy is supplied. So energy here is supplied. So just looking at the reaction profile, we can actually say whether this reaction is endothermic or exothermic reaction, and we can draw the energy profile for both of these. So let's understand more about the energy change of the reaction. So during the chemical reaction, what happens and why there is a change in the energy between reactants and products. First of all, energy must be supplied to break the bonds for the reactants. So in reactants, we have different molecules and each molecule have bonds between the atoms. So the energy needs to be supplied for these bonds to break. We know that for any bond to break, we will need to supply energy. So this is why we need a minimum of activation energy or a minimum amount of energy or activation energy for the reaction to start. And then when bonds are formed during the formation of the product, energy will be supplied. So energy will be released. So breaking of the bonds will need energy to be supplied, and the formation of bonds energy will be released. So the energy needed to break bonds and the energy released when bonds are formed can both be calculated from bond energy. So if you know the bond energies of all the bonds, then you can calculate the energy needed to break the bonds and energy needed to form the bonds. And we can calculate the overall energy change by simply calculating the sum of energy taken in to break bonds minus the sum of energy released to form bonds. So there are two cases here, two types of reaction, endothermic and exothermic. So if the energy taken during the breaking of bond is higher than the energy released when the bond is formed, then that means this is an endothermic reaction. Now overall energy was taken in. So the overall change that more energy taken in than the energy that was released. The other type of reaction is when the energy taken in to break the bonds is less than the energy released when the bonds are formed. Then this is going to be exothermic reaction. The reason behind that is because the energy released is higher than the energy, the total or the sum of the energy that was taken in. So the overall change is that energy is released or given off to the surrounding. Can we calculate this energy? We can calculate this difference in energy between reactants and products and the overall energy change if we use the bond energies. So for a reaction like this one, a reaction between hydrogen molecule and chlorine to give two molecules of hydrogen chloride. If you get a question like that in your exam, normally you will be supplied with the bond energies for all of these molecules, all types of bond energy. So we have three bonds and three types of bond energy. The first one is hydrogen-hydrogen bond, and the bond energy for this one is 436 kilojoule per mole. And then we have the chlorine, the one between the two chloride is 242 kilojoule per mole. And then we have the hydrogen and chloride bond, which is 431 kilojoule per mole. Now we need to calculate the amount of energy that is used to break all the bonds and the amount of energy that was released when all the bonds was formed. So first of all, the energy needed to break the bonds would equal the energy needed to break this bond between the two hydrogen and this bond between the two chloride. So we know that the bond energy for the hydrogen is 436 and for the chlorine is 242. So the overall energy needed to break all the bonds is 678 when we added these two values. And then we need to also to calculate the energy released when we made the new bonds. So we made two molecules of hydrogen chloride. So we know that the bond energy for hydrogen chloride formation is 431. So we must multiply this by 2 because there are two bonds that have been formed. and the total is 862. Now we need to calculate the energy change. So the overall energy change will equal the energy required to break the bond, which is 678, minus the energy released by forming the bonds, which is 862, and this will give you minus 184. Because this value is a negative, that means this is an exothermic reaction. Exothermic reaction means that this amount of energy was actually given off or released into the environment or into the surrounding. If the value is positive or plus, then that means the energy required to break the bond is higher than the energy released, and that means that the reaction is endothermic reaction because more energy was needed